What's up everyone, Lakonde Mwile here, back with another video, and we're talking K8s. In a previous video, I covered mTLS and Istio, but this topic is broader than the scope that I covered in that particular one. Another related aspect that I didn't deal with then is certificate management. And certificate management in Istio is at the heart of issuing identities to workloads in the service mesh. This is what enables mTLS. If you watch that video, you'll remember I mentioned Istio has its own certificate authority, or CA. But what if we want to configure it to use an external certificate authority and essentially change the hierarchy, having an intermediary CA and an external CA? Let me start by discussing why this can actually be useful. For starters, it allows you to create a shared root of trust in large-scale setups. If you want to establish trust beyond the scope of the mesh on a single cluster, an external root CA can provide that for cases like trust between meshes and workloads across separate Kubernetes clusters. Also, if your root certificate authority's private key is stored as a secret in the cluster, you need to work hard to make sure you lock things down to prevent that sensitive data getting breached in any kind of way. Alternatively, an external root CA or dedicated solution can help offload the overhead of managing that entire process. And third, in some cases, company policy may actually just dictate that you use an external centralized system for certificates of end users, devices, and workloads. All right. Let's look at how things work without an external CA in Istio. So I'm talking default configurations. Now, this has been covered to some degree in that previous video, and because there's relation between the two, there will be some overlap. Workloads in Kubernetes are identified using service accounts. If you don't specify one, Kubernetes will automatically assign one to your workload. And also, service accounts automatically mount an associated token, and this token is used by the service account for workloads to authenticate against the Kubernetes API. Now, the service account may be sufficient as an identity for Kubernetes, but if our workload is going to be part of the Istio service mesh, this won't be sufficient because Istio has its own identity management system and certificate authority. When a workload starts up with its Envoy side proxy, it needs an identity assigned from Istio in order for it to be deemed as trustworthy and allowed to communicate with other services in the mesh. To get this identity from Istio, the Istio agent sends a request known as a certificate signing request, or CSR, and this gets sent to the Istio control plane. This CSR contains the service account token so that the workload's identity can be verified before being processed. And this verification process is handled by Istio-D, which acts as a registration authority. The registration authority serves as a gatekeeper to make sure only verified CSRs make it through to the certificate authority. Once it's verified, it will be forwarded to the CA, which will then issue a certificate containing the SPIFFE identity with the service account. This certificate is called a SPIFFE Verifiable Identity Document, or SVID. And that's the general flow for assigning a verifiable identity in Istio's service mesh. By default, Istio's control plane fulfills the role of both the registration authority and certificate authority, specifically the Istio-D and Citadel components. But how does it work with an external CA? And there are different approaches you can take. The model I'm going to use will include Cert Manager. Cert Manager is a K8s add-on that manages the lifecycle of TLS certificates in Kubernetes. Instead of Istio's control plane, I will configure Cert Manager to be the CA. However, because I'm going to have an external CA, Cert Manager will be an intermediary CA and the external CA will be the root. When you create an external CA, you can generate the root public certificate that will be used to sign certificates for the intermediate CA. So moving forward, any certificates issued by Cert Manager are validated by the root CA. Remember, as I said earlier, it's basically a shift in the hierarchy. So my intermediary CA is going to be Cert Manager. But what about the external CA? In this case, I'll be using AWS Private CA, but you can use others that integrate with Cert Manager, and I've put a link in the description below for you to see the other integrations. Now, to configure Istio to work with Cert Manager, I'm going to use the Istio Certificate Signing Request Agent. Henceforth, Istio CSR because that's a mouthful. Istio CSR is a Cert Manager add-on, and this agent allows Istio workloads and control plane components to be secured with Cert Manager issuers. Remember, in my case, AWS Private CA. Istio CSR exposes the same service that Istio-D serves in the default config of validating incoming certificate signing requests, except after verification, it will convert those requests into resources that Cert Manager supports, like integrations with external CA issuers. So whenever there's a CSR from a workload, it will be forwarded to the Istio CSR. The Istio CSR acts as the registration authority. And remember, the RA is a gatekeeper verifying requests before forwarding them to the CA. Also important to remember, my CA is no longer Istio, it's now Cert Manager, which is actually the intermediary CA. Cert Manager's add-on agent will be configured to request certificates from AWS Private CA. How's that going to work? This communication between Cert Manager and AWS Private CA is enabled by the AWS Private CA Issuer plugin. And Cert Manager uses this plugin to request TLS certificates from that particular entity. Issuers in Kubernetes represent the CA from which signed certificates can be obtained. This issuer plugin will communicate with the AWS Private CA service to request a signed certificate for our workload. And once the certificate has been signed, it will be returned to the Istio CSR, which will read the signed request and return it to the workload that initiated the certificate signing request. Let's take a look at this in action. In the previous section, I covered the flow of interaction between the different components when a workload sends a certificate signing request. What I want to do now is provide a bit more context regarding the different components and the roles they play from a setup perspective. We essentially want to have an answer to the question, how do these components interact before Istio workload starts sending CSRs? And this is especially important to understand how everything works together. It will also help you understand things better from a setup configuration perspective, because there are different components that you're going to be installing and they'll have some custom configurations, and you want to know exactly what's happening and why certain things are going on in the background. Now, a lot of this will be documented in the README of the associated repository. Also, a quick note, this is contextual to my solution, which includes AWS Private CA. Things will look a little different depending on the external CA solution that you decide to go with. For example, the AWS PCA Issuer plugin, as you would guess, is specific to this particular root certificate authority. Okay, so the first thing that I need to do is create my certificate authority in AWS Private CA. And once I've done that, I can download the root public certificate either from the console or the AWS CLI. The next thing I need to do is create a secret based on this particular certificate so that the certificate is stored inside of my cluster. The secret is going to be saved as Istio root CA. Then I need to install Cert Manager. And you can do this either using kubectl or Helm. And remember, Cert Manager is going to replace IstioD as the root, as the certificate authority. In the bigger picture, Cert Manager is the intermediate certificate authority, whereas AWS Private CA is the root certificate authority. So Cert Manager, which is the component over here, is taking over responsibilities as a C from IstioD as a CA. Now, in order for Cert Manager to do this, I need to use an add-on agent known as Istio CSR. And Istio CSR will essentially convert the incoming certificate signing requests to resources that Cert Manager understands so that it can fulfill the role of a CA. It will convert those CSRs to resources that Cert Manager actually supports. And now, because I'm using an external certificate authority to issue certificates, Istio CSR needs to be configured to reach out to the correct issuer to sign the certificate requests. If you're familiar with Cert Manager, then you will know that you can use Cert Manager without external issuers, but it's a powerful tool that is extensible. And in my particular case, it's very useful for the kind of solution that I am going with over here. So for Cert Manager to integrate with the AWS Private CA, we essentially need a bridge or a component that will enable this. And for that, I'm using the AWS Private CA Issuer plugin. And it integrates with Cert Manager to enable communication with the root certificate authority. And this plugin should actually be installed before Istio CSR. And I'll explain why in a moment. So just to bring it full circle, just to bring things back so that you're following, first we create the certificate authority, download the public root certificate, store that as a secret, named Istio root CA inside of the cluster, and then I install Cert Manager, but I don't install Istio CSR just yet. Next, I need to install the AWS PCA Issuer plugin. And after that is when I install Istio CSR, and I'm going to provide clarity on why I do things in that particular way. Istio CSR will be configured to mount the root public certificate, which is stored in this particular secret. In order for Istio CSR to have verification and to communicate with the root certificate authority that it's going to be communicating with. So as soon as Istio CSR is installed, it is going to request certificates from the root certificate authority, which it needs to do in order for it to get set up as an intermediate certificate authority. Remember, Cert Manager is the intermediate certificate authority, and so it will need a root certificate of its own, and it'll also need some keys. So that root certificate authority, that root certificate that it gets assigned is going to be stored as a secret called Istio mTLS. And it will also create a certificate resource in the Kubernetes cluster that will be saved as Istio. So that's the reason why we need to have the issuer plugin installed and running in our cluster first before we install Istio CSR, because once we install Istio CSR, that is going to essentially be the process of setting up Cert Manager to be the certificate authority. So it will need to have the relevant certificates in place issued from our root CA. So it basically needs to be able to have a bridge to AWS Private CA in place before it can get the certificate that it needs. Okay, so the last step is to then install Istio. And when installing Istio, you will configure it to disable Istio from functioning as the default certificate authority. And instead, you're going to configure Istio to point to Cert Manager Istio CSR as the certificate authority. Istio will also be configured to mount the Cert Manager certificates as well as the secret Istio TLS, which contains the Istio CSR or the Cert Manager certificate, which is very important, root certificate at that. After that, workloads in the mesh can then start sending certificate signing requests. So I hope that helps provide a lot of clarity of how these different components interact before workloads start sending CSRs. All right, now let's look at some of the actual configurations. I'm not going to go over some of the more obvious steps because those will be in the README as I mentioned earlier. First, because the AWS Issuer plugin is going to be communicating with the service in AWS, your workload will need to have permissions for making the relevant API calls. And over here is a policy with the necessary actions needed. I prefer to manage all my infrastructure through Terraform, so let's take a look at that. I'm going to scroll up slightly. All right. So as you can see, I have three resources. One that manages the attachment of the new policy to the existing IAM EKS role. And in addition to that, I have another resource for the actual policy being created, which is this one over here. And lastly, the policy document, which limits this to the relevant actions that I want to be able to carry out against AWS Private CA, and you can see it's limited to the single resource that I have running in there. Now, very important, a more secure approach would be to use OIDC because of the session tokens that actually expire, and you can also narrow down the permissions. With this approach, every node in our cluster has the permissions, and by implication, every workload that runs on my EKS nodes. And that's not a secure way of managing things because only the AWS Issuer plugin needs those permissions. All right, let me head back to the README over here. So the issuer resource will reference the appropriate ARN and the region where it exists. So once you've installed the plugin and you've got the permissions in place, you'll need to create an issuer resource. And you can see over here that this one is a cluster issuer. Obviously, as you can tell, the kind is a custom resource definition, but you can also create an AWS PCA issuer, which would essentially be scoped to a specific namespace, but a cluster issuer, as the name implies, has the scope of the whole cluster. And you would, under the spec configuration, you would specify the relevant ARN and the region where your certificate authority has been created. Next, let's take a look at the additional configurations that I apply when installing Istio CSR. So I'm going to scroll down further over here, and Istio CSR is the second last step. Remember, you already need to have your AWS Issuer plugin installed, and you need to have created your issuer, because Istio CSR will be communicating with the issuer in order for it to communicate with AWS Private CA. And as you can see, under some of these specific Helm values, I am updating the issuer group, issuer kind, and name, and I'm specifically pointing to the AWS Private CA issuer. This is very important. The name is arbitrary, of course. This one is taken from the cluster issuer that I created, so make sure that you are aware of that if you're going to follow this exact same approach. And in addition to that, Istio CSR needs access to the AWS public root certificate. Remember, that was something that I walked through in the diagram. And so I mount the relevant secret. Remember, the AWS private certificate authority has a root public certificate, which I'm storing in the cluster as a secret named Istio root CA, which is this one that is being mounted over here. And then just another important note is that I am preserving the certificate requests because I want to be able to show you what these requests look like. And so I've set that to true by default. This is a value that is false. And generally, you wouldn't want to keep these unless you actually do want to keep track of all the certificate requests. Okay, so now we've had a look at that. The next thing we can do is head over to K9S, and I want to show you an example of a certificate request along with the certificate and secret, specifically the flow from the moment that you install Istio CSR. If you remember the diagram, I'm just going to quickly open it over here. I told you that once you install Istio CSR, it's going to send a certificate request to AWS Private CA to be assigned its own root certificate. And when it gets that certificate, it will be stored in a certificate resource in the cluster. And that same certificate will also be stored in a secret called Istio mTLS. So I'm going to head over to K9S. And I'm going to go to certificate requests. And remember, because this flow is what happens from the get-go, before any workloads can start sending requests, it is the first one. So I scroll right to the bottom, and as you can see over here, the certificate request is for Istio D. You can see the issuer over here, AWS Private CA, which is the same for all of them. I'm just going to describe. And as you can see, the certificate name is Istio D, as I pointed out. And this is going to be stored in a secret called Istio D TLS. I'm just going to scroll to the bottom just so you can see this. You can see the issuer reference over here. And all the way to the bottom, you can see that the certificate the certificate request had been approved and was issued. So let's take a look at that. You can see that the certificate was created. Its name is Istio D and stored in the Istio system namespace. And the relevant secret that stores the same certificate is Istio D TLS. And there's the secret that I was referring to. Okay, so when all that is set up, your workloads can start sending certificate signing requests. So let's take a look at a certificate signing request that is more relevant to the workloads. Now that we've got Istio CSR set up, which is essentially our certificate authority within the cluster, even though we've got an external CA. Okay, just so you can see, there's a difference. Though the one right at the bottom was the first one, because that was when Istio CSR was getting set up, which is why it's different. It's Istio D. So now let's take a look at one for one of my workloads. Okay, so here's one. And right at the top, you can see in the annotations, we've got a spiffy ID. And remember, I spoke about these earlier. And remember, a spiffy ID contains the namespace for a particular workload. So we can see e-commerce over here. And I've got an e-commerce, I've got e-commerce microservices, and they're all using the default service account. So that's what's being referenced over here. Now, because these workloads inside e-commerce are all part of the Istio service mesh, in order for them to communicate, they need to mutually authenticate. And so this is an example of one of those requests. And so I'm going to scroll down, and you can see over here, similar to the Istio D certificate request, we've got our issuer and the actual request. If I scroll down a little bit, you can see under usages, we've got client authentication and server authentication. It's an example for that mutual TLS. Then we see the status, which includes the CA, the certificate, and right at the bottom, we can see that the certificate request was approved and the certificate was issued. All right, before I show you mTLS in action, I want to show you my Istio custom configurations. And remember, in order to install Istio in this particular way, you just have to initialize the Istio operator. You can use the istioctl command line tool, and all you have to do is run istioctl operator init, and that will install the operator on your cluster. And after that, you can simply create a Kubernetes resource manifest like the one that you're looking at right now, and essentially define the custom configurations you want for Istio and apply that to the cluster, and the Istio operator will manage the installation according to what you have specified. Now, you can see I'm specifying over here that this is going to be deployed into the Istio system namespace. I'm calling mine Istio. That is an arbitrary value. If you want to call yours Istio control plane, you can go ahead and do that. I'm defining the profile here as demo. You might be familiar with that if you typically install Istio using istioctl and you specify a profile. Now, really important, based on what we've been discussing, is the CA address. You'll recall I mentioned that I change my Istio configuration to point to Cert Manager to have it as its certificate authority, and this is where I do that. The CA address is pointing to Cert Manager Istio CSR, which, remember, is that main component that's going to fulfill the role as an intermediate certificate authority. In addition to that, I'm disabling Istio-D's default functionality as a certificate authority. So this is where you would manage that. And then the last thing is just modifying my Istio-D deployment as well to mount certificates from Cert Manager. And this is all of these configurations that I've put in place over here, and it would take a while to go through these step by step. But I do also want to show you that I am referencing the secret Istio-D TLS. And if you remember, Istio-D TLS is that secret that stores the certificate for Cert Manager Istio CSR, essentially the certificate authority for the service mesh, the intermediate certificate authority. All right, so here are the workloads that I was just referring to. You can see the Node.js application here, which is called Express Test, and here are my e-commerce applications. And the e-commerce applications are running inside of the Istio service mesh. And something else that I've done is I have created a peer authentication resource, which is what is used to manage mTLS in Istio, and I have set it to strict mode, as you can see over there. Now, by default, Istio has mTLS enabled, but it is set to a permissive mode. But I have updated it to a strict mode. So what I'm going to do now is I'm going to attempt to communicate from this Node.js application to one of the applications running inside of the service mesh, and it should reject it. So this is just a test to make sure that issuing of certificates is working as expected with this entire flow with AWS Private CA as the root, Istio CSR as the intermediary certificate authority, which is basically just an add-on for Cert Manager. All right, so we want to shell into this. It's one thing to have shown you all the other components, but this is what it all comes down to. The actual applications to make sure things are working as expected. I'm going to try and communicate with the orders service, which is running in the e-commerce namespace. And it is running on port 3003. And this is one of the endpoints. And you can see the connection was reset by the peer. The Express Test application can't communicate with it. What we're going to do now is test this out. with an application that actually is part of the mesh and send a request to orders service, and this should be successful. And you can see the request was successful. That means that mutual TLS or mutual authentication is taking place within the mesh with this new certificate system that we have in place. If I run a cat command on that returned request, you can see over here, this is the response that I got. It was successful. So that brings things full circle.